Disclaimer. This episode discusses the design and manufacture of firearms. I am not an expert on the subject. The purpose of this story is to educate and entertain. Do not try anything I describe here yourself. I would probably get myself killed if I tried to do this in real life, and so would you. It should also go without saying to never aim a firearm at anything you don't want to completely destroy, and never to aim one at another person except in self-defense, when it's either you or them. Anything else is mean, and you will inevitably hurt more people than the ones you shoot at, by taking them away from their friends and family forever, and that includes you. This will create a chain reaction of suffering inducing more suffering in the world via the butterfly effect that you can prevent by choosing not to propagate it. If you feel like hurting yourself or others, please seek counseling, like I did when I was angry and depressed. It may take a while and a lot of work, but go easy on yourself. Having gone through it myself, I can assure you that it will get better. Thank you. Also, just a heads up, this one's going to get a bit loud and noisy. Asyle, Tropical Island Survival. Week 28, Day 1. After my morning chores, I got to work on my plans for base defenses. I've been thinking a lot about that gun idea, and I think the easiest way to make it, because I don't have the proper equipment for forging, is electrolysis again. I can grow an iron cylinder around a conductive carbon mandrel to build the barrel, and probably some of the other parts too. But to do that, I'm going to need a larger container to electroplate in, which will also come in handy when I inevitably start making metal plates in bulk, rather than having to smelt ore in the kiln. I spent some time in the morning building a concrete trough like the one I made for the explosive machine, giving it a bamboo frame, handles, and wheels to help me move it around like the wheelbarrow, and putting little grooves in the walls where I could slide in plates later for bulk electroplating projects. In the end, I think this is going to be a more efficient way to make metal parts than melting or casting, even if it takes longer, just because it's wasting less energy as heat. While I was in the workshop, I started making a mount for the dynamo. I couldn't really hook it straight to the water wheel, nor would that really have done much good. So I drilled into the wall a little to make a place for some axles, and I made a couple of wheels of different sizes, and pulleys from rope soaked in rubber. The idea was to put one large wheel on the water wheel, and connect it via belt to a smaller wheel on the wall next to it. This would cause the little wheel to rotate much faster. The little wheel had another big wheel on the same axle, and the same thing would happen again, getting the wheels and belts moving very, very fast. The second small wheel was connected to the dynamo axle, and hopefully that'll give me more electrical power. Just in case the increase in power ended up being marginal, I left room to extend the length of the dynamo so I can add more sections and coils if I need to generate more power. I gave it a test and had to make a few adjustments to keep the dynamo from coming apart at the speeds I was running it at, but it seemed to be working. Nice to have the lathe back at least. I realized at this point there was one more thing that I needed to do for the larger electrolysis rig, and that was to find a way to capture and use the gases produced by the reactions for future chemistry experiments. My old electrolysis pot has naturally been producing a lot of oxygen gas, but the bubbler hasn't been available to help me capture and process it into potassium peroxide because I've been using it to make nitric acid instead. It wouldn't really have worked anyway because there was no reliable source of heat to power the reaction in the workshop, nor would it have been practical to pipe a hose all the way from the workshop to the lab. This meant that, besides a lid and hoses for the electrolysis tub, I would need to make some kind of container for transporting gases. I doubted I could capture oxygen in a pot and transport it to the lab, so instead, the simplest solution I could think of was to make a balloon. I affixed some clay balls to the ends of sticks and dipped them in latex, leaving them out in the sun to dry. Once dry, I should be able to peel them off and have some nice balloons, which should also function as little pumps for the bubbler, because they'll be storing the gas under pressure. While I was playing with clay, I made the lids to sit over the electrolysis tub, and integrated some plugs into it where it'll be easy to attach balloons or hoses to pipe away the gases. I realized at this point, though, that I would need a way to keep the rig pressurized, otherwise the gases would be forced into the balloons. The rig wasn't really designed for this, so the best solution I could come up with was to make a latex seal later and put some weights on the lids to keep the gas pressure from pushing them up and opening the seal. I had a little time before lunch, so while I was in the clay, I made one more item, and that was a dripping spout that I could attach to my teapot crucible. The idea here was that I could make the shot for my shotgun rounds by just dripping molten lead into water. Surface tension should cause them to mostly form into a ball, but that requires keeping the molten lead from dripping out too fast, or letting the droplets get too big. I erred on the side of making the spout too small, since I could always make it a little bigger. Besides, if I can make something like birdshot, it'll definitely hurt an unprotected person, and they'll spend days digging the BBs out of their skin, but short of an infection, it won't kill them. Just leave them thinking twice about messing with me again, which is all I'm really after. After lunch, there wasn't a lot I could do for the gun while I waited for the parts to set. This was going to be a prep day, so while I waited, I got started on the second tier of my defenses, and that was the parametric array. I checked the ethanol distiller, filtered out the solution from it, mixed in the washing soda, and left the Rochelle Salt solution to crystallize in the cellar again. I made some new molds for the solution to crystallize in, improving on the previous design, mostly carving pieces of bamboo and bamboo partition into specific shapes. The idea is that they'll crystallize mostly into cylinders, which will slip nicely into a bamboo holding frame later, but with a thin void space in the center and a leg on either side. This is so that, when the crystal expands and contracts, the part in the middle will expand and contract the most, and have room to bend, moving the air like a speaker. I poured my solution into these molds, and put the bottoms of them directly against the cooling elements in the freezer, so they would crystallize first, while trying to keep the upper portions warm and insulated using rocks heated in the solar kiln, and some clay for insulation. The temperature differential should force crystallization to start at the bottom of the molds early, and prevent smaller crystals from growing elsewhere in the molds, which would create polycrystals instead of monocrystals. I still had a few hours to kill at the end of the day, so I started thinking about a few other parts I would need to make for the defensive system, like a circuit board to regulate the outputs of the parametric array, and mirrors for the solar tower. I probably won't be able to work on most of that until tomorrow, but what I could get done today was a bit more clay work for another breadboard. So I spent some time working on that. I'll probably need both kilns tomorrow. While I was at it, I made a special lens grinder for the solar reflector, if you can really call it a lens. I did my best to make the hollow space inside the grinder a perfect cone with 45-degree sides and a little taller than the windows in the solar kiln, using a small frame of wood and cord and carefully trimming it to shape on the lathe. The idea is that when the cone is lifted into the center of the kiln, where all of the beams from the reflectors converge, it'll focus all the reflected light down in a mostly straight line onto another flat mirror, which will allow me to direct the beam wherever I want it to go. They'll need to be mirrored with silver, but that'll have to wait until later. In the meantime, I should do some planning for my parametric array circuit. This is going to be tricky, and something I've definitely never done before, not least of which because each crystal is going to need to be running at a different frequency and phase. I don't think I can build a unique circuit to drive each one, but I don't think I'll have to. Depending on the beat frequency I want between the different crystals, I should only need a minimum of 2 interacting frequencies of sound, so only 2 oscillator circuits. With the spare parts I have left over from the radio project, I should be able to build a couple of astable multivibrator circuits, which will actually be useful for this application. And if my memory of simple harmonic oscillators is still accurate, all that's necessary to change the phase of an oscillation is to add a damper to it, or in this case, a resistor, though not too big, otherwise the vibration will be completely damped out. I can build one variable resistor to tune each crystal individually, and then add a resistor of the proper value in its place before moving on to the next one, which will take some time. For tonight, though, I worked on building that variable resistor and assembling whatever capacitors, resistors, or transistors I figured I would need moving forward. Unfortunately, I was unable to finish because I ran out of thin copper films. It's a good thing I have a few cast plates in reserve. I'll have to melt them and make new copper films tomorrow, but I'll have lots of smelting to do anyway. Week 28, Day 2. I put my clay parts in the kitchen kiln to cook in the morning, because I would be needing the solar kiln for smelting later in the day. Once I was done with my morning chores, I immediately checked on the electrolysis tub to check that it was set, before filling it with a solution of water and electrolyte. I realized at this point, however, that I'd made a mistake in my haste to get the tub built. Namely, I can't put sulfuric acid in it, otherwise it'll dissolve the lime in the concrete. I poured in some potash to act as an electrolyte instead, which would also help capture any sulfur that leaches out of the iron ore during the reaction and protect the tub. Once all that was set, I trimmed down a piece of bamboo on the lathe to a length that seemed roughly appropriate for a shotgun barrel, not that I've ever handled one before, and I coated it with carbon paint, though I left a gap where I expected the rounds would have to be ejected and reinstalled into the barrel. I then set it gently into the solution on some stands, poured in all my separated iron pyrite ore, and wired them both up to the dynamo, making sure to connect the lead to the mandrel as close to the firing chamber as possible, since the resistance within the carbon should cause the iron to collect there first, and thus make it a bit thicker to help handle the pressure from the exploding rounds. I'm not even going to bother trying to melt any of the iron ore down this time. My kiln will never reach that temperature. If I want iron tools, this is how they're getting made. Almost immediately, the reaction started producing some bubbles, which was a good sign that it was working fast. I couldn't capture those bubbles until the lid pieces were done, but I didn't mind losing a little. I was in a bit of a hurry. By that time, the solar kiln had finished warming up, so I started smelting, beginning with the lead ore. Once it was melted, I added a little bit of nitric acid to the ammonia solution that I bubbled into the metal to get the silver out, as I expected this to make the reaction much more complete compared to last time, though I took care to use a pretty dilute solution of nitric acid, so I wouldn't burn myself or my equipment. I also stayed as far away and upwind of the crucible as I could during this operation, to avoid inhaling any toxic fumes from the reaction. Fortunately, there was a lovely sea breeze coming in over the canopy at the top of the solar tower. I decanted the liquid silver nitrate from my lead, this time getting a much larger amount, before setting the lead aside, as I forgot that I couldn't create my shot drops until the spout I built for it was finished cooking. In the meantime, I melted down my copper ingots, and made about half of it into thin films, and the remainder into wire, so I wouldn't run out during future projects. I stopped for lunch at this point, before collecting and separating some sand for making glass. I figured I might as well, while I had some extra lead to pour it onto. By the time I was done collecting the sand, the clay parts were done firing, so I let them cool a little while I brought the sand up to melting temperatures. Once it was ready, I poured most of it repeatedly into my molds for glass panes. I left an obstruction in the center of one of them to make the pane into a sort of donut shape, and I saved one glob of glass and rolled it around on a flat clay surface until it was a rough cone shape, which I could grind down later with my new grinding head. Once I was done with the glass, I reheated the lead and started testing my pouring of lead shot into a pot of water. The BBs came out misshapen, a bit bigger than I was hoping, and highly variable in size, between 2 and 4 millimeters in diameter in most cases. So perhaps a little closer to buckshot than birdshot. Still, I didn't think I could make them any smaller without plugging up the spout completely, so I made what I thought would be enough for several rounds. It was kind of sobering to realize that I might have to actually kill someone in order to survive here. As I swirled around the lead shot in the bottom of the pot and let it slip through my fingers a few times, I felt a little sick at the prospect, and my heart started feeling as heavy as the lead balls in my hands. I had to shake myself out of it and think about what I needed to do next. I took my glass cone to the workshop and started it grinding, and then went to check on the Rochelle Salt crystals, which I probably allowed to crystallize a little too long. Still, with a little finagling, I got them out of their molds, carefully ground off the excess crystal, and put it back in the solution to start another round overnight, especially since several of the crystals I pulled were polycrystals instead of monocrystals, and needed to be remade. Though, to help the process along, I did my best to only remove the smallest crystals from these oscillators, leaving the biggest ones to continue growing. I then finished building the electronic components I figured I'd need for the oscillator circuit tomorrow, but I found myself exhausted, more emotionally than physically, because I felt so conflicted, and just rested a while at the end of the day before cleaning up and getting ready for bed. Week 28, Day 3. After my morning chores, I checked on the gun barrel, and more or less as expected, it had built up a film a little less than a millimeter thick on it. It was nowhere near finished electroplating to its proper thickness, but there was something else I needed to do with it first. A nearly pure iron gun barrel like this one would never work effectively because pure iron is quite ductile and would bend and bulge from the heat and pressure of the exploding rounds. I needed steel, which meant I needed to get carbon into the iron. Normally, this is accomplished by melting or softening the iron with coal during the forming process, which I'd do. However, I could still get a little carbon into the iron by case-hardening it, which basically amounted to cooking it in coal for several hours at high temperatures. The carbon in the coal diffuses into the hot metal, creating a thin layer of high-carbon steel near the surface. By doing this repeatedly over the next several days of electroplating, the barrel should form alternating layers of soft and hard metal in it, which should give it the best qualities of both. This was another thing, though, that I didn't entirely think through when I started this project. Otherwise, I might have made a clay container for it the other day when I was making all the other clay parts. I wasn't too worried about it, though, because this was, ideally, a one-time project. So I took my gun barrel out of the electrolytic solution, put it in the solar kiln before it got too hot, packed coal around it, and then covered the coal packing in wet clay to keep it from burning. This clay covering was going to crack for sure, but at this point, I considered it a little expendable. It's not like I don't have a mountain of the stuff lying around. I surrounded this with wood and let it burn in the solar kiln. I wasn't sure how long I was supposed to burn it for, so I decided to give it about the same amount of time as my pots normally took, just to be on the safe side. In the meantime, I figured there was no point in wasting the electrolysis tub, so I got the clay plating surface from the older, smaller cell and set it up inside the tub to begin making a spare plate, which I'll use to build the firing mechanisms for the gun later. Next, I started building and testing my circuits for the phased acoustic array, making a pair of tunable, astable multi-vibrator circuits. Once I was done with them, I stopped for lunch, as there wasn't a whole lot I could do with them until I'd finished growing more crystals. There wasn't a lot I could do with the solar Dazzler scheme yet either, because the solar kiln was occupied, so I figured there was nothing to do but get on with the uncomfortable job of making ammo for the shotgun. I started by getting some bamboo of appropriate sizes and trimming them so they would have partitions on one side but be open on the other, just like an empty shotgun shell. Next, I mixed some nitric acid with the leftover sawdust to make a batch of nitrocellulose propellant. Next, I needed to think about a way to set off the ammunition with a striking pin, since nitrocellulose isn't an impact explosive, as far as I know. Nitroglycerin, on the other hand, is, but I didn't like the idea of the rounds potentially exploding in my face if I dropped them. Another option I considered was something like a flintlock ignition system, almost like a poppet built into the bottom of the rounds. But again, they would probably be unreliable and go off if I dropped them. I think those use something a bit more reactive than gunpowder anyway. I thought a little about this and came up with a relatively simple solution. Put the firing caps on the outside of the shell. Unlike a normal shotgun round, mine are made of wood instead of metal, which is much weaker. By making a divot in the partitions of my bamboo rounds, but not going all the way through, and by designing my firing pin so that it contains the explosion of a nitroglycerin firing cap, the explosion should burst what's left of the partition and set off the nitrocellulose inside. However, if the round is outside the gun when the firing cap explodes, it'll disperse in all directions, and there won't be enough pressure to set off the round. I knew this would take some precision, and the thicknesses of the partitions were variable, so I built a jig for my drill press that would keep the drill head from going all the way through the rounds. Again, just leaving that little divot. By the time I was done drilling divots into all my shells, it was coming up on the end of the day, and I removed my shotgun barrel from the kiln. Fortunately, it hadn't deformed from the heat, but the mandrel inside had turned to charcoal. That was fine, it did its job, but I needed to make sure that the barrel thickened outward instead of inward, so after removing the remains of the old mandrel, I made a new one on the lathe just to fit inside the barrel and restrict further electrodeposition to the outside, before wiring it up and putting it back in the electrolysis tub, making sure to collect any oxygen gas produced in the meantime with my balloons. Before the day was done, although I was running a little behind, I checked on my Rochelle Salt crystals and gave them the same treatment as yesterday, getting a few more perfect crystals out of the mix and plenty more imperfect ones. Week 28, Day 4. After my morning chores and after electroplating all night, I started the gun barrel case hardening again. I guess this is going to be part of my routine for a while. I figured I had enough crystals at this point to at least begin tuning the right frequencies for my acoustic array circuit. I can adjust the phases later. First, I tested my crystals to make sure they worked and wouldn't shake themselves to pieces, or what volumes they tended to shake themselves to pieces at. This reminded me of another thing I needed to worry about, namely that these crystals are water soluble, and it can get kind of humid around here, so to protect them, I gave them a thin coating of latex before moving on. Once I started playing around with the circuits, I found that actually getting the crystals to produce an audible frequency from ultrasound was kind of easy. First, I tuned up the frequency of the multi-vibrator circuits until I couldn't hear them anymore, and tried to get the two crystals I was working with to be at about the same frequency, indicated by my no longer being able to hear the beat frequency between them, just like tuning a guitar. I could then leave one of the circuits as the bass frequency and adjust the other relative to it until the beat frequency between them produced an audible tone. For the moment, that tone was weak, because the waves were spreading out in all directions, rather than being focused in a single direction, but that's what the phased array is for. Nevertheless, I worked on selecting and fixing a frequency for each circuit, so I didn't have to worry about it changing unexpectedly later, and so I could reuse the potentiometers. I tried to set the base ultrasonic frequencies as low as possible for a couple of reasons, but mostly because it made the range for adjustments that I needed to make much broader if the frequency was lower. Shorter wavelengths meant a smaller adjustment would produce larger relative changes between the sound waves, and my equipment wasn't exactly made for precision, so I'll take all the help I can get. This should also apply when I start making the phase adjustments too. While this will require larger resistors and sap more energy from the vibrations than smaller ones would, the trade-off is greater precision, and getting dozens of micrometer length sound waves to line up just right is going to take a lot of precision. I tried to get the final frequency to be as ear-splitting as possible, coming up with about 10 kHz, which actually feels like there's someone pressing their thumbs against my eardrums. Perfect. Once I was done with my experiments, I built a frame to hold the crystals in an array once it's finished, so I can begin experimenting with phases. It was mostly a bunch of bamboo caps stuck together in a sort of honeycomb pattern. I marked half of them for one frequency and half of them for the other in a repeating pattern, trying to keep them as evenly distributed as possible in the array. When I was done, it was time for lunch. After lunch, I got back to working on the ammunition project, carefully mixing up some droplets of nitroglycerin and testing their ability to burst or not burst the membranes I prepared for them yesterday. This took a lot of fiddling and adjustment to get to a point where I was confident the membranes would burst under the action of a firing pin, but not when thrown to the ground. Of course, the pellets of nitroglycerin and taro powder kept falling out of the divot, so I found it was easier and safer to paint a coating of latex over them to hold them in place and protect them from accidental impacts. The term rubber bullets came to mind, and that gave me an idea for some less lethal ammunition. Police around the world use rubber bullets for crowd and riot control in emergencies, and while they can still cause serious injuries and even death in some cases, they'll cause much less damage than an equivalent metal round, because the rubber squashes and spreads out on impact rather than passing through a person's body, generally resulting in massive bruising. This option frankly lifted my spirits because I really didn't want to kill anyone, though I'll still make a handful of lethal rounds just in case I have no other choice. Making rubber into perfectly round shot balls was going to be tricky, but I had an idea and prepared some latex with vinegar to harden before pouring the mixture into some creosote or hot coconut oil and mixing vigorously. Because latex dissolves in water and water doesn't mix with oil, the boundary between them caused the latex-laden water to form bubbles in the oil, which wouldn't be perfectly round or uniform in size, but would be close enough. In case the rubber BBs wouldn't be adequate, however, I also cast a few rubber slugs, which will individually carry much more kinetic energy. I expect enough to potentially crack a rib, though my rubber bullets won't be nearly as destructive as the real ones used by police forces, since theirs are actually metal coated in rubber, or rubber with a ceramic filler, to give it more mass. With my heart a little lighter about the whole prospect, I started carefully packing the shotgun rounds with the nitrocellulose I made the other day, so they'd be ready for loading tomorrow once all the shot was set. I did load a few with lead shot though, since it was ready, wrapping it in a leaf to keep it tightly packed in the shell and to help keep the expanding gases from the shotgun round from escaping around them and forcing all their energy to go into accelerating the shot, kind of like a sabot. Finally, to keep the BBs from falling out, I coated the end of the round with latex and left those ones to dry overnight. I also marked these ones with red ink to remind me that they were the deadly ones. By the time I was done, so was the shotgun barrel, so I set it back in the electrolysis tub for the night, checked on my Rochelle Salt crystals again, and got ready for bed. Week 28, Day 5. I did my morning chores and swapped the gun barrel into the kiln again in the morning. I figured I had enough crystals at this point to at least get started on the phased part of the phased acoustic array. This one required a bit of math, because the idea is that the waves will all reach the same point directly in front of the array in this case at the same time, and because the waves have known, or at least calculable, lengths, and are a specific distance away from the center of the speaker, I can measure that distance and calculate just how much of a phase shift is necessary for each crystal. I was a little worried at first that the phase shift would be too small for me to accurately measure, but fortunately for me, with the speed of sound in air being 343 meters per second, the wavelength of a 10 kilohertz tone is about 3 centimeters, giving me plenty of wiggle room in my calculations. Of course, that was just for the beat frequency, not the signal frequency, but even a 35 kilohertz wave has a wavelength of about 1 centimeter. 350 kilohertz would probably have been about the limit of my physical resolution, at about 1 millimeter, but that was way higher than I needed the frequency to be. Since the crystals were arranged in a more or less hexagonal formation around the center of the array, I could calculate the phase shift for one ring of crystals at a time, and hook them up to a single circuit, saving me time in tuning the phases. Then it was just a matter of building the circuits, which was easier said than done, because phase is a difficult thing to measure, especially when you can't see the waves to know it's working right. The best thing I could think to do was to try and set up a standing wave between the acoustic array and a flat clay tablet to reflect the sound back at it, laying some sand and dust on the desk between them, which formed into distinct lines where the standing wave was. This took a significant amount of fiddling, and had to be repeated for each array ring to help me dial in the correct phase, but it turned out to be an invaluable tool for helping me visualize the otherwise invisible. My math helped me get into the ballpark of the resistances I needed for each ring, and the potentiometers, when wired in parallel, sometimes several times over, helped me dial it in. It seemed to take forever, but eventually I got the phase shift circuit completed. It's basically one big mess of resistors on a breadboard, but I'm really thankful that I figured out that shortcut of setting up the crystals in rings, because now all I have to do as I get more crystals is wire them into the circuit I have. Otherwise, I'm basically finished, excepting a field test. I stopped for lunch after this, and then got back to my ammunition, removing my rubber bullets from setting overnight, and putting them in the pressure cooker to vulcanize, though I had to cook them in the kitchen kiln for today. Once they were done, I poured and sealed them into the empty shells I prepared the other day. All I need now is a gun to test them in, though again, the thought makes me very uncomfortable the closer I get to actually using it. I painted these shells with a green pigment to remind me that they were the supposedly non-lethal rounds, and I set them aside to dry. Next I started working on the solar Dazzler. I collected the glass parts I needed to silver, including the glass panes from the periscope that I didn't have enough silver to mirror before, along with my silver nitrate from the other day. I boiled some sugarcane, gathered the other requisite chemicals, and proceeded to silver the panes and polished reflector cone, which didn't take more than a few minutes. Next, I needed to start thinking about the aiming system for the light beam. As I mentioned, the cone would reflect the light down and out of the kiln, and a mirror underneath it would reflect it out and away from the tower. This was an easy apparatus to build, simply mounting the cone upside down on the end of a bamboo pole and threading it through that donut pane at the bottom, cocked at an angle. However, the floor of the solar tower got in the way of aiming the light at anything in the courtyard, and I wanted to be able to control all my defensive systems from the panic room anyway, so I set up another mirror on the railing of the solar tower to direct the beam towards my periscope. This created a new problem, however, because 1. I didn't want to reflect the beam into my own eyes by accidentally looking at it with the periscope, and 2. Even if I didn't, the light beam wouldn't reflect off the periscope mirror in the same direction that I was looking through it, because my sight line and the Dazzler beam won't be at the same angle. However, I figured I could make a third mirror underneath the periscope, with a hole I could look through and aim the solar Dazzler at. That way, the light beam should go wherever I aim the periscope, but without getting in my eyes. Of course, bouncing the sunlight off of 5 mirrors is going to reduce its power significantly. Even if they're 90% efficient at reflecting light, that's going to result in a total power loss of about 40%. Even so, that's going to be up to 4 kilowatts of sunshine delivered directly to the face, or 40 times the brightness of the sun, though probably much less. It certainly won't be enough to cook anyone, but could easily cause temporary blindness, which is sort of what I'm aiming for. To accommodate this, I'll need to build a mechanism to raise the periscope up a bit so the lid will be out of the way of the light beam. This shouldn't be too hard though. I'll start working on it tomorrow. With the time I had before evening though, I built the necessary mounting rigs for the mirrors and aimed the dwindling sunlight at the periscope when I went to remove the gun barrel from the kiln and wrap up for the night. Week 28, Day 6. I did my chores in the morning and swapped out the gun barrel again. I measured the thickness to be about 3 millimeters and figured it was probably pretty close to finished, so this would be the last time. Once that was set, I started taking apart my periscope to begin mounting the Dazzler and Acoustic arrays to it. The first thing I did was add some rails and pulleys to the mirror mounting frame at the bottom, along with a handle to rotate them. This allowed me to lift the periscope up a foot or two, which exposed the Dazzler mirror to the beam of the solar tower, but otherwise kept it hidden and protected. By itself, this didn't affect the functionality of the periscope, except for one thing. The small hole I put in the Dazzler mirror wasn't very large, so it restricted my field of view. However, by adding a couple of lenses to the periscope, I figured I could set their focal point at that hole and basically squeeze the image through it so it wouldn't get in the way anymore. Of course, that was another engineering catch-22, because the lenses would get in the way of the Dazzler beam and spread it out to the point that it wouldn't be blinding anymore. What I came up with was to put a sort of telescope inside the hole of the Dazzler mirror, out of the way, but which could basically magnify the image from the periscope mirrors and guide the light through the hole. I had a few spare lenses from my last optic projects, so I built a bamboo tube to hold them in place and mounted them and the Dazzler mirror in the appropriate positions on the periscope. I spent some time running up and down the stairs between the roof and the panic room, tweaking the focal length so that everything worked correctly, but eventually I was satisfied with the optics. Adding lenses made the images a little bit greener and a little bit darker, because the lenses weren't gathering light across as large an area anymore, but I could still see. I also noted how I couldn't see the smuggler's bunker when the periscope was raised like this, because the mirrors were now out of alignment, but I figured I wouldn't need to. If I have to raise the periscope, I've got more immediate problems. I had a few more crystals I needed to mount on the acoustic array, and once I was done installing them, I figured the array had enough of them to begin testing its long-range effectiveness. I mounted it to the axle of the periscope mirror so that the acoustic array's sound beam would be pointing wherever I was looking. To keep the circuitry safe, I ran what I considered to be a somewhat indulgent amount of wire down the periscope so I could keep the circuitry and lead-acid battery down in the panic room, where I could conveniently turn the array on and off. Once I had it set up about how I wanted it, I aimed it at one of the wind pumps for the solar tower and walked out to see how effective it was. The sound was a bit more spread out than I was expecting, though still mostly focused around that spot. It was more annoying than it was painful, so I spent about half an hour tweaking the phase circuits just a little bit more until I had it pretty focused and could barely stand in the path of the beam for more than a few moments. It literally felt like someone was pressing on my eardrums with their fingers, even when I covered my ears. Perfect. I stopped for lunch around this point before preparing some of the final components of the shotgun. I chopped down some bamboo and built a frame to hold the barrel and firing mechanism. This mostly consisted of a split, hollowed, half piece of bamboo that I planned to tie the finished barrel into, and several other pieces bent into arches to form a lightweight frame for the butt of the gun. I designed several of these arches to function like bowstrings to help absorb the recoil of the gun. Reminds me of the weapon mods from Fallout 4. Those kinds of upgrades were always locked off for all but the highest leveled players, and here I was building one out of sticks. It makes me think about how technology doesn't have discrete or arbitrary levels to it, the way some folks will talk about some technology being more advanced than others. It's all the same physical principles, no matter how or what you make them out of. If you know it, you can make it. Maybe that's why I found the upgrading system in Subnautica a bit more compelling. Enough talk of video games, though. Once I was done with the gun frame, having lightly pogoed on it a few times, I started working on the firing chamber and firing mechanisms. These were some of the most intricate mechanisms I'd built yet, in addition to handling some of the largest forces, so I had to make everything as beefy as I could. The idea behind how most guns work is that when you pull the trigger, it releases a catch holding the firing pin back against a compressed spring. Once released, the pin flies toward and strikes the firing cap on the shell, exploding the propellant and sending the ammo flying forward. At the same time, it sends the spent shell backwards, resetting the firing pin for the next shot. Usually, there's also a little mechanism that kicks the spent shell out of the way and pulls a new one out of the ammo magazine, so you can keep pulling the trigger without having to think about anything except what you're aiming at. I realized from thinking about this that the trigger and firing pin wouldn't need to be quite as robust as I feared. I could probably make everything except the firing pin itself out of wood, mostly because if I used a sliding cylinder of bamboo about the same diameter as my shells to strike the firing caps, all the force of the explosion would be distributed evenly across the surface of that cylinder, and I could just have my firing pin poking out of the center of it like a nail. I probably could have gotten away with using a piece of ceramic or glass, but I didn't want to take risks with something that's literally designed to kill people. So I spent some time grinding a narrow sliver of iron from the spare plate I'd been growing and trimming it to a point. Actually, it was more like a triangle that poked out of the end of the firing mechanism, so I could distribute any forces acting on it evenly. It occurred to me that this would need to be case-hardened as well, so I hastily packed it in coal and put it in the kiln. It won't get nearly as deep a carbon layer as the barrel, but it shouldn't need one. I then got back to the rest of the firing mechanism, making some sturdy rubber bands to absorb the energy from the fired shot and reset the firing pin. The trigger was also a fairly simple mechanism, simply being a catch on a pivot to hold the firing pin back. I carved that out of wood easily and used a little rubber band to incline it to click back into place the moment the firing pin had completely recoiled. I was able to easily embed this mechanism inside the bamboo handle for the gun, so it would be protected from the elements. Finally, I concerned myself with the reloading mechanism, and had the idea to actually make this part of the trigger mechanism. When the firing pin fully retracts, and the trigger is free to click back into place, the rubber band pulling it back into position would also flick the spent shell out, by basically attaching a long inclined plane to the trigger. This would be accomplished by the next round, under pressure, sliding up the plane and pushing the spent round out half of the way, with the trigger mechanism lifting the new round into place and pushing the old round out the rest of the way. This required a slight change to my plans for the firing mechanism, however, in that the firing pin would have to accelerate the shell as well as itself into firing position when the trigger was pulled, but this didn't cause too many problems. I cut and hollowed out a piece of bamboo to sit under the barrel of the shotgun and hold a few shells, with a rubber band mechanism to hold them under tension until they were all pushed out, much like a real shotgun. I affixed a short half piece of bamboo to act as my inclined plane or scoop for subsequent rounds. It took some fiddling and several extra catches I wasn't planning for, but eventually I got it working, testing it mostly by manually pulling the firing pin back and looking for points where the rounds sometimes caught. The manual pullback mechanism for the firing pin was also a good safety feature in case a shell failed to go off or jammed inside the barrel, which I expect will happen often. At the end of the day, when the barrel and firing pin were finished case hardening, I removed them and decided it was finally time to fit everything together. I cleaned off the barrel and slid it into the gun frame, carefully trimming as I went to make sure everything fit as snugly as possible. I tied it to the frame using mostly cord and even added a couple small pegs and rings of bamboo to act as targeting reticules, not that I was likely to need to hit anything at a distance. I made several dry runs with blank rounds to make sure everything was still working correctly with the new barrel, but I didn't plan on conducting a firing test tonight. I just got my last round of crystals from the cellar, cleaned up, and started getting ready for bed. Week 28, Day 7. It's Sabbath today, but I still had a little work to do before I could consider my defenses completed. After my morning chores, and taking some time to relax and introspect, transcribing my radio recordings and listening to the sermon on the radio, I installed the last few crystals in my acoustic array before testing it and the solar Dazzler together. I realized as I was doing this, though, that getting the reflectors into the kiln wasn't going to be a quick and easy process, which was a problem because I may not have time to get it all set up in an emergency, especially if there's already something cooking inside the kiln. I'd have to pull myself up there in the elevator, remove the floor of the kiln, lower the elevator to push it out of the way, put the reflector in just the right spot on the roof of the elevator, and lift the elevator back up into place. I can't just leave the reflector in the kiln either, otherwise it would be in the way. In a lot of ways, it would have been easier to have built all these defensive systems into the tower rather than my panic room, but I still feel like I would be less of a target down there. Besides, it already has a turret on it. Unfortunately, short of making a mechanism to completely automate the entire process, 5 to 10 minutes of forewarning will have to do. However, since they arrived early in the morning last time, I could make it part of my routine from now on to install the solar reflector in the kiln before I go to bed. That way, it'll be ready first thing in the morning if I need it. From the periscope, there was a clear and convenient circle of bright light at the center of my field of vision that made the acoustic array much easier to aim. I put on my armor and goggles for protection when testing the array on myself, but even with all that equipment, the burning light of 40 suns and screaming noise on my eardrums was so absolutely unbearable that I couldn't stand in the target zone for more than a few seconds. This'll definitely send anyone who isn't already blind and deaf running for the shore. Next, I decided there was no avoiding it any longer. It was time to put the shotgun to the test. I was a little excited, but also nervous. Mostly nervous, because this thing scares the hell out of me. I whipped up a frame to hold the gun steady, and set a log in the line of fire for testing the damage and lethality of both rubber and lead shot. I tied a cord to the trigger and hid behind a tree while I pulled it. There was a loud bang, and frankly I consider it a miracle that the gun didn't completely blow itself to pieces. The barrel seemed to be intact, though the wooden shell was obviously pretty worse for wear. Scorched and cracked, but it didn't splinter, probably due to the relatively thick walls I gave them relative to real shotgun shells. For safety, I tied the rubber bands a bit too tight, so the first shot didn't reload properly. I adjusted and tested again several times, until I was convinced that the gun was able to fire reliably, checking for any components that may have been wearing out as I went. The barrel itself certainly seemed capable of handling the stress. The hard rubber bullets caused some superficial damage to the wood I put in their path, and created massive pits in a piece of breadfruit I used for a crude tissue test, but they didn't actually go all the way through, which told me they were probably not lethal. The lead shot, on the other hand, completely pulverized the fruit and left splintered craters in the log. I'm terrified at the thought of using this on another human being. I almost want to throw those rounds away, but fear tells me to hold on to them for the absolute worst case scenario. I kept telling myself that I probably won't need them. Even so, I'll probably need to make more rubber rounds later. For the time being, however, I stored it all in the panic room next to my armor and took a lunch break. When I was done, now having gotten myself all riled up about coming under attack again, I spent the rest of the day making a second batch of rubber rounds. Since I had a better idea of what I was doing, the process was easier and it wasn't particularly hard work to begin with, just tedious. At the end of the day, I had about 30 rounds of the rubber shot and 10 rounds of the lead. My arm reloaded and my defenses finished on time. I went to bed noticing that being prepared only puts part of my mind at ease. Another part was made even more nervous. I think this is because I know that, although I have the power to defend myself now, my survival will still be dependent on my performance. And I've never been good at performing under pressure. Blooper Reel. I can grow an iron cylinder around a conductive carbon mandrel to build the barrel, and this is why I never carry my phone with me. I spent some time in the morning building a concrete trough like the one I made for the explosives machine. Oops, totally lost my place. Pause. For bulk electroplate, and pulleys from rope soaked in rubber, and pulleys from rope soap poured in all my separated iron. Take me down. Take me down. I then finished building the electronic components I figured I'd need for the oscillator circuit tomorrow, but I found myself exhausted, more emotionally than physically, because I felt so conflicted. I think I need to change the energy on this recording. I checked on the gun barrel, and more or less as expected, it had built up a film. Excuse me. A nearly pure iron gun barrel. A nearly pure iron gun barrel like this will never work effectively. It'll disperse in all directions, and there won't be enough pressure to set off the round. Again with the sneezes. Which actually feels like there's someone pressing their which actually feel which actually the boundary between them caused the boundary between them caused. However, the floor of the solar tower got in the way of aiming the light at anything in the courtyard, and wanted to be able to and wanted to yeah, there should be an I in there. Typo. The sound was a bit more spread out than I was expecting. Holding the firing pin back. Holding the firing pin. What? So I spent some time grinding a narrow sliver of iron from the spare plate. So I spent some time grinding a narrow sliver of iron from the spare plate I'd been growing. From the spare plate I'd been growing and trimming. The spare plate I'd been growing and trimming it to a point. Okay, and pushing the spent round the spent round out halfway. And pushing the spent round out halfway. Out halfway. Out halfway. And pushing the spent round out halfway. I spent the rest of the day making a second batch of rubber rounds. Enunciate. Perfect. Hey there, thanks for listening all the way to the end. Those of you who could still hear after I tested the phased acoustic array, that is. Sorry about that, by the way. With any luck, the smugglers will hate it just as much as you did. So, if you want to see how that turns out, you can press the subscribe and bell buttons below the video to get notified as soon as that episode's ready. It never hurts to have backup, though, so it would really help me out, more than anything else, if you could share this video with someone who you think would enjoy it. And since you enjoyed it enough to watch it for this long, there's a like button you can press if you thought it was brilliant. I hope this video was a little ray of sunshine that brightened up your day. Also, if you'd like to chat about your own stories and perspectives on the episode, though I can't in good conscience recommend sharing tips and tricks for making weapons, feel free to share them in the comments section below. I'd love to hear them, and I'm always open to suggestions and corrections. Even though I try to do my research, this whole thing still feels like a shot in the dark. That said, thanks again for listening, and hope to see you here again next week.